In this short video, we're going to look at the last of three techniques for solving quadratic equations, and it's the quadratic formula. Now we need a standard form. So we have one side equal to 0, and we write the quadratic term first, then the linear term, then the constant term, and we are standardizing that the coefficient on the quadratic term is lowercase a, and then the coefficient on the linear term is b, and the constant term is c. And the only restriction we have is a cannot be 0. If a were 0, then we would not have a quadratic equation. But b and c can be any numbers. So what we do is we say, well, if I have this generic equation with a, b, and c, I can solve it by completing the square. And then in the end, I'll have a formula for x in terms of the coefficients a, b, and c. So we'll start by multiplying both sides by 1 over a. And then I want to have the x terms on one side of the equation, the constant term, which is now c over a, on the other side of the equation. And now what do I need to do? I need to find the value of b and b squared. So 2b, and I'm talking about uppercase b, is lowercase b over 2. So b over 2a is the second term when I find the factorization. And squaring that is b squared over 4a squared. That's what needs to be added to both sides. Now again, I don't need to think about the factorization. I know it's going to be the binomial x plus b over 2a quantity squared. Though I do need to do some algebra with this minus c over a plus b squared over 4a squared. So let me do this over in the margin. I'll need a common denominator, so I'll need to multiply the negative c over a by 4a over 4a. That gets me negative 4ac plus b squared. And we can rewrite that with the b squared minus 4ac. But I don't know why I didn't write that. I wrote 4a squared. So let's go ahead and fix that. There we go. And I'll have to fix it on the other slides as well. That we'll get rid of and replace it with a c. That's what it should be. And over here we'll do the same. So now I have the binomial x plus b over 2a all squared equals b squared minus 4ac all over 4a squared. That part is correct. Alright, so let's go ahead and correct this here as well. B squared minus 4ac over 4a squared. Use the square roots property. Oops. Get that as the correct term. And 3 more places to get it to be 4ac. AC. And in the last equation, it's correct, but let's go ahead in the work and make that 4AC. B squared minus 4AC. So what have I done here? I went ahead and took the square root of top and bottom, so I'd have square root b squared minus 4ac over 2a, and now I have a common denominator of 2a, so I can write that as a single fraction, negative b plus or minus square root b squared minus 4ac all over 2a. So that's our quadratic formula. If you're going to use this, you're going to have to memorize it. I won't let you have a cheat sheet. It's not that difficult. So let's solve this equation using the quadratic formula. I need to write it in standard form. So I'm going to make one side equal to 0. And then I need to identify my lowercase a, b, and c for the formula. So a equals 3, b equals negative 8. Be careful about those negative signs. And c equals positive 2. So now it's just a matter of substituting it in and working it out according to the order of operations. So I'll have a 64 and then minus 4 times 3 times 2. That's minus 24 all over 6. And this radical 40 since 40 is 4 times 10, I can write that as 2 times radical 10. And then I see that I can actually factor out a 2 from each term, and that's what has to be done, right? You have to have it a common factor, and then I'm left with, in the bottom, 6 can also be factored as 2 times 3, so I've got this form of 1. So it actually simplifies to 4 plus or minus radical 10 all over 3. Now, this term, or expression, b squared minus 4ac, under the radical sign, we call it the discriminant, because it really tells you a lot of information. And so d equals b squared minus 4ac. If this is a positive number, then we know we're going to have 2 real solutions. If it's negative, you'll have 2 imaginary solutions, or complex solutions with a non-zero imaginary part. We'll be seeing those when we look at complex numbers. If d equals 0, then you have only one real solution. We say it's repeated. We'll talk more about that in a later chapter. And then finally, if d is positive and a perfect square, then I will get rational solutions. So remember, no quadratic. Rational solutions have no no square root sign in them. And that, moreover, that tells me that we can factor the equation. So if we're asked to factor something and we think that it's prime, well, we can check by calculating the discriminant. If the discriminant is not a perfect square, then you have a prime polynomial. If the discriminant is a perfect square, then it can be factored.